Hello, everyone. Hello, Yogesh. Am I audible? I guess Suresh is here. Kendall, can you make Suresh the host?
Yep, we'll do.
Hey, Parthiban.
Hey, Suresh. Yeah.
Oh, Kendall is hosting today. Hi, Kendall. Good morning.
Yeah, Kendall is our prime host who is helping us.
Okay. So we have thin attendance as of now. Let's wait for a few more minutes. Maybe another couple of minutes before we start.
Yep. Sure, Suresh. Hello, Hardik. Still, we have one of our guests, Hardik is also going to be a co-host here today. He's going to share the dice with Suresh. So you can keep him also as a co-host so that he can share screen.
Hey, Hardik. Good morning.
Hello.
Yeah. You're audible, Hardik. I think things are good. So we are waiting for a little more people to come in and we'll get started.
Hardik, we have to admit here, today Kadri is having a challenge. They have in Canada nationwide network down. So he will not be able to present in this meeting today. So I'm feeling for him today. And it's nice background, Hardik.
Sounds good. Yeah, thank you. I'm sure you'll do excellent. Looking forward to it.
So.
Okay. Good morning, good evening, everyone. This Magma 5G, everything you need to know meeting is starting in a couple of minutes. Usually we have an attendance of 50 plus. So we are expecting a few more people to join. So let's start maybe in a minute from now. All right, I think we can get started, Hardik.
Okay, Anshu, would you like me to go first?
I'll share screen and set the agenda, and then I'll hand off to Yogesh and Parthiban, and then subsequently they will hand off to you.
Okay, sounds good. Thank you.
All right. So good morning, good evening, everyone. Welcome to the Magma 5G Everything You Need to Know meeting. This meeting happens every second Friday of the month. So the agenda for today's meeting is we have Hardik Jain as a co-host from GenXCom, and Kader Khan from Wavelabs is to be the host. He is from Canada, and in Canada today they're experiencing a nationwide network down. So for that reason, I'm feeling for him. I am Suresh from Wavelabs, Vice President of Engineering, looking into the Magma-based connectivity product solutions, and also a number of connectivity solutions we build out of Wavelabs connectivity practice. So the agenda for today's meeting is first 5 minutes, I will cover enabling adoption of Magma for 5G, and then I will hand off the baton to Yogesh and Parthiban to speak about the features that are in development and the features that are ready to make it to release 1.8 of Magma, and then test and operations update. And then we invite the co-host today, Hardik Jain from GenXCom. They are building a number of radio systems. They are also interoperating with Magma 5G. So Hardik Jain is going to talk about GenXCom ecosystem for Magma 5G. And then we have 10 minutes towards the end of the meeting to go over the questions, and then the plan for next meeting, and we'll close the session subsequently. So with this agenda in place, I go on to talk about enabling adoption of Magma for 5G. So why Magma? Magma, you can consider an edge core, and it is primarily pretty much suitable for FWA and private 5G solutions. And as such, when you look at Magma adoption, the promise that the industry holds is 5G private networks are exponentially getting created and getting adopted in the market. So that's the reason we're giving emphasis on private 5G networks, and Magma can be adopted for private 5G deployments. And why this meeting today? Our objective is to enable engagement of the community in the adoption of Magma. So in that context, we want to present what is available in Magma for the adoption of FWA and private 5G solutions, and what is the promise from Magma community for the next half year. So to present that, we are here in this meeting. 5G is to play a big role in the Industry 4.0 ecosystem. You look at the manufacturing industry and a number of manufacturing industry sectors and other industry sectors, the 5G use cases, say for example, it is enhanced mobile broadband, EMBB, or Internet of Things, or mission critical services. All of them are holding a huge promise in terms of adoption of the private 5G solutions. So it means there is going to be exponential rise in the adoption of Magma as well, because Magma is primarily targeted for the edge use cases, particularly in the enterprise space. The strategy we have adopted for Magma is 2I strategy. It is expertise and ecosystem. When it comes to expertise, we in Wavelabs have taken the commitment to upskill developers and testers in the Magma ecosystem. And in the city of Brampton in Canada, with the city administration and testopper community, Magma community and Wavelabs started hosting decoding 5G sessions to upskill a number of developers and testers in the Magma ecosystem. And Wavelabs also have contributed to the telecom infrastructure project, FWA 5G test plan. So this is on the expertise side, and in the ecosystem side, look at the Linux Foundation open source components for 5G. You have Magma as the core, and around that, there are a number of other open sources in the Linux Foundation. Say the RAN, and then on the edge, and also on the management plane, there are a number of open source components in the Linux Foundation. That is on the open source ecosystem. And when it comes to the partner ecosystem, on the radio side, we have GenXCon, and on the core network side, we have Wave Labs. And on the management side, we have Arna Networks and Rebecca as a test product vendor. And also on the management plane, we have Calum and Ternium. So this is the open source ecosystem, and then the partner ecosystem we have for the adoption of Magma. Say any open source, particularly in the telecom business, needs ecosystem. So that's the reason the Magma community also has given high emphasis on ecosystem. And to enable adoption of Magma for the community users in the Magma Slack channel, Wave Labs have dedicated a channel by name Wave Labs 5G support. Anyone who wants to adopt Magma 5G can come and ask questions related to the versions of open sources that go well with Magma. And also, if you have any questions related to the platform or the configurations, feel free to come and ask. Our group of Magma specialists from Wave Labs will support you in the configuration and also in the deployments. So if you want to try it live to experience in the first place, you can reach out to Wave Labs 5G support asking for an instance of Magma orchestrator that is deployed in the AWS. And in Wave Labs, we have AGW hosted in our hardware servers. So you can log on to the AWS hosted Magma orchestrator, and you can run the 5G call flow on the Magma AGW hosted in the Wave Labs. And a number of hardware platforms in multiple form factors can be used to support Magma. So with this introductory, I will hand off the baton to Yogesh and Parthiban to take you through the Magma 5G features, and then what are the Delta updates between last meeting and now on the dev, test, and operation side. Over to you, Yogesh and Parthiban.
Thank you,
Thank you,
Suresh. Yogesh, you can share and continue.
Sure. Give me a second. Is my screen visible?
Yeah.
Yeah,
Please.
we can see your screen.
Sure.
Yogesh, go ahead.
Yeah. So yeah, thanks, Suresh, for the giving the overview, setting the context. So I'll just jump on to the dev updates. It's always good to tell like what is already existing, and then what we are doing as part of release 1.8, the next upcoming release. So the features which are already delivered as part of 1.7 and they are already in master for 5G is all the basic MVP features like registration, authentication, PDU session, and usage reporting and charging. So all these features are already present as part of 5G, which got delivered as part of 1.7 release. That was named as the 5G SA Alpha. This was the first time where 5G got introduced onto Magma. Moving on to 1.8, Now it has been thoroughly tested with on a lot of simulators and the real equipments. And together with hardening of the features, we have added few more critical items. Mainly, we have focused more on the QoS part, the feature parity for with 4G, that is the stateless, and network session modification, SUSI extension, IPv6, GTP extension for QFI. Then we have done some hardening related to security in orchestrator, and we have supported this HTTP full and partial reset. So most of the components are already in 1.8, apart from this session modification and GTP extension. It's primarily we have been testing it with different kind of simulators, open source and commercial, and more hardening was going on. So from last meeting to this, it's mostly the hardening and the hardening of these features on different platforms, I would say. What is the current status of Magma in 1.8 for the 1.8 release? All the features which are like QoS, SUSI extension, IPv6, they are all in. Let's say if you want to test this feature, we can get it to the master and test it. And the ones which are going to be landing hopefully by early next week is network initiated session modification and GTP extension for QFI support. Coding for both is done. All the reviews, basic sanity is done. Hopefully, if everything goes in well, it will be landing by next week, and then we will be ready for all the basic features will be in for 1.8. For this, for the purpose of meeting, we have chosen two topics, or rather three topics, which we want to show a small demo. First one is related to the network initiated session modification. The entire flow is meant for creating dedicated QoS flows. And if MNO wants to change some QoS policies because of some reason, dynamically, we can enable it via this feature. The complete flow will involve PCF from the MNO core. And this information, as it gets passed to session D, FEG, and via AMF, it will be synced in with UE and GNB, and the fast path will be installed accordingly. And mainly, it can be used for, giving, installing special QoS rules when the bandwidth exceeds, or, any higher bandwidth requirements suddenly surge. We can do this on demand with this feature. On the right hand side, it's just some packet snapshot where all these features what are getting configured is getting reflected. This is a small call flow which we have prepared, starting from right hand side, the PCF. This going to send a message to session D. There are a lot of layers, but we have tried to simplify it. And then the session D with all the processing requests AMF to get it policy validated with UE and GNB. Then the AMF will send this request to UE, which will accept or deny it. Assuming it's an accept case, the session D comes, the message comes back. The rules are installed in pipeline D, and then the PCF is notified about it. So here we have shown the flow from Magma perspective. Like session D is loosely mapping to SMF, pipeline D to UPF. So the names are a little different from 3GPP, but the flow we wanted to show was from the Magma perspective. The next feature we have been working from, which we have been working for hardening, is the GTP extension. This was a little tricky feature because we have to make the feature available in Open vSwitch, and the particular patch was there in the kernel module of it. So the main changes were extending the processing of the GTP packet for the extension headers. natively it's not there as part of OVS. So we have added the code to do the processing. So with this change, any packet coming with this QFI will be allowed and will be mapped according to the rules. And the same will happen on the outgoing side. The particular packet will be mapped with a specific QFI. So on the on the left hand side, we are just showing the incoming and the outgoing tables, where we just wanted to highlight that only a packet, if it has a matching QFI, will be allowed and mapped to the QS rule. And down we are showing the outgoing rule. So the packet will be marked with this QFI 6 as it goes out from the AGW towards GNB. Yeah, this is again some packet captures which we have taken from our notes. On the left hand side, we can see it's the downlink packet and the QFI getting attached. On the right hand side, it is the uplink packet which is received, which have the QFI, and both are getting processed. I think most of the testing we have done from the past was related to the Dockers. There has been a lot of efforts which have been put to containerize the AGW. Builds are getting more and more stable, and people can start making the Docker images and then try it out. So already the efforts are on for making the basic call flows. All the basic sanities are going good. I think soon the official images will be available, which we can plug into the CI jobs. There is a lot of discussion going around to make this happen. So as part of this activity, what we have done is we have taken the Docker and the Dockerized part of AGW, and we have checked that all the basic 5G call flows are going fine, and there is no issues with the basic call flow. Of course, more elaborate testing we are targeting for 1.9 because there is a lot of features, performance, scaling we have to test. So the target is 1.9, but we have ensured that all the basic call flows, if somebody wants to try, it will be working successfully. On the right hand side, we just wanted to show the snapshot of what happens when the Dockers are launched. Not all the containers are covered, but just to give a highlight of it. I think those are the main things which we have hardened or added from past release. Suresh, should we start the demo, or we will continue with Parthivan and then we'll take it in the end?
Yeah, I think you can go ahead and finish your demo. Otherwise, we're having a lot of handshakes between both of you.
Okay. Yeah. So Ajay, Sridhar.
Yes, Yogesh. Yes.
Sure. So what I will do is I'll just start the demo, and I'll run through it. I'll present it, and then you can walk us through it.
Yes, sure.
So give me a second.
Okay.
I'll just start from beginning. Yeah.
Yes,
so
this is.
I think. Yeah. Sure. So Sridhar, continue.
Thank you, Yogesh, for giving the basic about all the features. Yes, this is the Spirent tool which we use it to test the special session modification. Yes, you can start the video. This is the test case which we use it to test the session modification. In this test case, we have done all the basic configuration which is needed, like MC, etc. And this is the AGW which is connected to that Spirent tool. So first we are checking the MME status. So yes, it is active and running. So can you move forward?
Sure.
Yes, this is the subscriber table. Yes, so a little bit yearly.
Sure.
Little.
Okay. Sorry.
Yes, we have started the test case. So after starting the test case, we got the we are gripping this MC to get the session ID. So after getting the session ID, so yes, can you use the here once?
Yeah.
Yes, this is a CLI command which we used instead of the, as there is no PCF, instead of that we use the stub thing to initiate the network initiated session modification. This is the CLI command. Here, this is session manager CLI.py. It has policy. We want to choose this policy rar. In that there is different documents like MC, session ID, policy action, priority, QCI, flow rules, QS. In policy action, we support addition or deletion, and in flow rules, there is a list of six tuples like direction, protocol, source IP, source port, destination IP, destination port. On QS also we have some seven like maximum UL, maximum bitrate DL, guarantee bitrate UL, guarantee bitrate DL, ERP priority, pre-capability, pre-vulnerability. Yes, you can start the video.
Sure. So yeah, I think just to add on, I think instead of PCF, we'll be simulating this with the command. So these are the different parameters. Yeah.
So the session ID which we captured, we are pasting here, and also we should use the APN which we use it to get the session establishment. Yes, you can run the video.
Sure. Yeah. So I think as Sridhar covered, I think the first parameter, the MC, the subscriber itself, and the second parameter tells within that subscriber, this is the session on which this operation is going to be performed. As this is a dynamic QoS, so we have to have the session beforehand to change the policy. Yeah.
So we should use the same APN which we use it for getting the P2 session establishment accept, the first P2 session establishment. Yes. Yes, you can move forward.
Yeah.
So yes, we got the APN in the subscriber table and we should paste there. Yes. Can you move forward a little bit?
Sure.
So we have copied that one. And before we pasting that one, we will just try to see the OVS table 12 once. So just use 1 second. Yes, if we see the OVS table here, we got the two lists, which is the default OVS table for P2 session establishment.
Yeah. So this table is mainly targeted for providing the QoS flows. So this shows the default QoS entries which is associated with the PDU session. This shows the entries, and after executing our command, we'll see the additional entries.
Yes. So we executed the command. This is the command. So after the execution of the command, if we check the session modification terminal, we can see the session modification got executed as the number increased to 1. So, and if we see the table 12 again, can you move forward a little bit?
Yeah, directly jump to the additional entries.
Yes.
So,
yes, these two. Yes. These two are the additional entries which we got after applying that session modification command. Please move forward. So same how we have done addition, if we do we can do the deletion also by putting the del in the place of add. So if we done the deletion, now we are deleting that the newly applied QoS rules. So after that we can see the session modification got increased to 2. Yes. Let's move forward a little bit. So after, as the session modification, and then we are stopping the test case. After stopping the test case, we will get the PCAP. from these parent test results. So we are just trying to download it and opening it. So here first we can see pdo session establishment accept. After that we can see pdo session modification command. If we open that message in the NAS part, we can see all the different things which are extended protocol, all the messages, and also in the QoS rule we can see create new QoS rule, which means this is the QoS rule which I have added. So, and it have packet filter which gives the information of IP address, IPv4 IP address, and also below to that IE there is QoS flow descriptions which gives the maximum bitrate and guarantee bitrate values. Maximum bitrate and guarantee bitrate values which we have added with the session modification command. And into this in ngp message also we can see all these values. Yes. So, and also in session modification we got other one which got triggered by you doing the deletion. If we open that one, move forward. Move forward. Yes, here in the QoS rule we can see the delete existing QoS rule, which means the newly added QoS rule will be deleted. So this is how we have tested session modification using Spirent.
Yeah, thanks, Sridhar. I think that is the end of our slide, right?
Yes, end of our video. Yes, thank you.
This is awesome presentation from Sridhar of Wave Labs in the community. So, Yogesh, here we need to make a time check. We are left with 30 minutes, means half the time is over. Another 10 minutes is there between you and Parthiban to go over the rest of the presentation from you and Parthiban.
So we actually had two more demos, but
Yeah,
I
you
think
can go ahead.
Yeah, sure. Yeah, so maybe we'll just quickly go through it. This is the demo for the GTP extension header. Lavanya, Prabina,
yeah, Yogesh. Yeah, thanks.
I'll try to slide it fast, but yeah.
Yeah, okay. So, okay, you can start the demo. I can explain a little bit. So, for a better understanding, we created subscribed two entries, like two subscribers, subscriber 1 and 2. So you can get it first subscriber will get like details more. So here you can see that class ID 8. So you are using class ID for that QFI identifier. So it's just like a 4G QCI value, the same value you are using for QFI. So this is class ID for 8 for that first subscriber, and you can go in second subscriber. You will see for different value you configure user. This is second subscriber, class ID is 6. So here we'll set that value all. Now you can using that simulator or URAM-sim, you will create a video section established for the two subscriber both. So here you capture that pcap. So here you just see URAM simulator. So you created, we create to, you can, yeah, you guys can continue. So here two video sections is established. You can get it IP address, and we'll see in the table 0 entries where you will get it that tunnel information tunnel. So here you can see first entries for QFI 6 where is created second, and second entry is QFI 8 for second for subscriber for uplink and uplink both, and then in middle you can see in local there are also QFI value 8 and 6. So this is for table 0 entries where for traffic flow is happening for the tunnel specified traffic. So it is specific QFI flow only is accepted for the QE. So we can send the traffic through that URMC, we'll get it, and then we'll collect that PCAP file, we'll see it. So so you have created two tunnel interfaces, what is the 13 dot interface and 12 IP address interface. So now we will do ping. So ping 888 under via this interface, 12 and 13 both interface tunnel interface. Yeah, traffic is ongoing. So and then the second interface will do same traffic will send for that 13. So here also will traffic will so then we capture that already is PCAP file. We will see that PCAP, you can transfer this PCAP and see that same like QFI whatever you set like 6 and 8, that is reflecting in for uplink and downlink both traffic or not. Yes, this is that traffic we are sending. So first we are sending 12. So here is we are going the traffic. We can extend it the traffic flows. We can so you can see that here you can see that flow identified is 8 is uplink traffic going. Then this is downlink traffic. This is uplink traffic. UL you can see that TL traffic we are going. This is same traffic we are receiving. So you can see that uplink and downlink same QFI 8 will going. Then another one is 13. We'll see. Let go down a little bit. We'll see for another UE. So this is another UE sections. Here you can set it to QFI 6. So you can see it like this is both the traffic uplink and downlink, or same QFI 6 you are using, and you are sending traffic and receive that inside UL and DL video section. So this is basically it's QFI related. More in a kernel, OBS kernel is supported only for default QFI is 9. So we added like in OBS kernel so that whatever user configure QFI value, that is receive and uplink and downlink will work to that QFI. That's it, you guys. Any doubts, anything?
Yeah, all questions can be taken up towards the end, Pravina and Lavanya. Thanks to both of you. This is awesome demonstration from both of you from Wavelabs.
Thanks, Suresh. Thank you.
Thank you, Suresh.
In the community, whoever wants to ask questions, feel free to narrate your questions in the chat. We can take up them towards the end of this session. We have 5 minutes dedicated for the Q&A.
Yeah, Suresh, so I think that this is our last demo. Mostly it is on the Docker containers, where we have shown the AGW Dockerized and the 5G call flow. So Shivesh, I think I'll quickly slide it. We'll just, so maybe can you start and then,
Yeah. Thanks for the introduction. So first we'll bring up the Vagrant VM, simple Ubuntu Vagrant VM. Inside that we'll bring up the access gateway.
So just for the interest of time, I'm just skipping it. So I think, let's just.
So now we'll download this Docker script from the Magma repo, and then we'll just change the interface name according to this script and reboot the Vagrant VM, and then we have to place the root C certificate from the orchestrator to which we need to connect. So first we'll create the file and copy the root CA certificate from orchestrator to the access gateway. And then we'll run the script. This is a script containing Ansible things and the packages which will help to install various packages in the Linux kernel. Once it's done, we'll reload the Vagrant, and our next step would be building the Docker images, but some packages were missing, so either we can apply it through the patch or we can do it manually. But manually is better because the code keeps on changing, so the patch may get older.
So this is the, at the time when we took this, so that some manual entry has to be done. I think it will be addressed shortly.
Yeah. So now we'll check if any Docker images are there or any Docker containers are up, and update the package repo so that so now we'll start building the images. You can skip 1-2 minutes, Yogesh. Yeah. So these are the Docker images that got built up. Now we'll bring up the Docker containers. Either we can do that by executing this script, or we can also use the simple Docker compose of the. So now the Docker containers are starting. Generally it takes a minute or two to bring up all the containers. So all the containers are here, and these are the various services of the orchestrator. Now we'll connect it to the orchestrator. Now in the NMS, we'll simply add the gateway hardware ID and the challenge key to add the gateway, to register the access gateway with the orchestrator.
So I think, yeah.
So we can now check it on the access gateway also if it's registered or not. You can CLI.py is used to check that. And yeah, it's showing connected. Now we'll check for the subscriber list if it's syncing from the orchestrator. You can skip 30 seconds. Yeah. So these 4 MC IDs are synced, which are there in the NMS orchestrator also. Now we'll check if 5G features are enabled or not. For that, we'll initiate a GET request. We can see that the 5G features are false, so it's not enabled. We need to enable it. For that, we'll initiate a put request and update the false value with true. Yeah. Then we'll execute it, and then we'll check it in the GET request if it's updated. Yeah, it's updated. So now we'll check in the access gateway. all the flags are true here, that means it's enabled. Now we'll add a new subscriber through NMS. We'll use this subscriber to get a basic end-to-end 5G call flow. So this subscriber is added now. It will take a minute or two to get synced in the access gateway. Here I have fastened the video. So let's check. Yeah, the subscriber is here. Now we'll get the information about this. Yeah, the information is there. Now we'll fill all this information in the OAI GNB-UE simulator. We have to fill the EMF, that is the access gateway IP address, correctly. Then the simulator's IP address, the MNC and MCC, the subscriber MC, auth key, auth OPC, and all should match. So we'll fill it accordingly. You can skip a minute, you wish.
Yeah, sure.
Yeah. So after all this configuration is done, we'll start our GNB and UE. Before that, we'll initiate a TCP dump to gather all the things in the pcap file. And then we'll start our GNB and UE. Now we can see in the HTTP associations that the things are getting sent. The connection has been established. The EPS also, we can see both ports are enabled. So now we'll exit this GNB and UE, and also this pcap file which is generated, we'll download it and view it through Wireshark. So when we apply an gap filter, we can see the whole basic 5G call flow is there. From
Awesome,
NG setup
Suresh.
request
Okay.
to
Yeah, awesome. So Magma AJW now runs on containers, though containerization is not officially part of the release yet. Thanks for giving this demo, Yogesh and Shivesh. We have little time left, so let's go on to test update. One, I think we need to hold up the update on the ops front. Then let's go on to directly to GenXCom radio node interoperability tests that are successful with Magma 5G. And then let's give time to our co-host, Hardik, to speak through. Over to you, Parthiban.
Thank you, Suresh. I'll just quickly complete the part of it. Yeah, so I think today we had a jam-packed agenda from the dev update. We have seen lots of features which are in working condition. We have seen a lot of demo. Yeah, quite all of the regression testing and all of the day-to-day run test or feature testing are in stable state. You could see that the Magma dashboard shows up all of the things in a green state. Okay, pretty much there were some build issues, but it is all getting sorted out and things are getting more stable these days. And we are continuing to do even the scale test over here, which we are doing it for 200 UE scale with 4 sessions per UE and 4 policy per UE with throughput of 400 Mbps and then attach rate of 5 attach per second. So the exciting part is we are able to do a real equipment testing with interoperability with along with BiCells we have added with GenXCom as well. That's where we have invited Hardik over here, who is one of our Magma community member as well, and he's going to share a lot more in this coming up time. So I could shorten my update, and we'll hear more from Hardik about the GenX interoperability, what more he's bringing into the Magma now. So that's it, update from my side. Yeah, maybe Hardik, you could share your screen and get started. Hardik, you are on
Sounds
mute.
good.
You're
Yeah,
talking on mute.
I got it. Thank you. Good morning, good afternoon, good evening, everybody. Thank you for joining us from multiple time zones. My name is Hardik Jain. I'm one of the co-founder and CTO at GXE, we're also known as GenXCom before. We are a telecommunications company based in Austin, Texas, in the US, building upon a unique technology that we're bringing to market for building a mesh, cellular mesh networks, especially on the mesh for the RAN, for making the deployments better and for giving a good experience like how Wi-Fi meshes today do inside our home. And so as a part of some of our R&D development, we're working on 5G. We're working on 5G standalone. And we're doing that for doing it for our just doing an end-to-end deployment and using Magma core for the 5G core network. And so I want to share a little bit more details about what we have done so far, and we'll be happy to take some questions about either the experience or some of the learnings or anything regarding the architecture. This is our kind of briefly describing our solution, our implementation of solution at a very high level. So we have a network management system connected with the core network, which can be on-prem. And then we have the, traditionally the radio networks are all fiber-based or they are Ethernet-based. That's how you're today deploying or building out your networks where you want a wired connection between the radio and the core. The next link that we have here, especially for outdoor and also for indoor, is a wireless link between. So imagine you have one access point that is wired connected, and then other access points or CBRS access points or any cellular access points that are wirelessly connected to the previous access point. That's what we are enabling right now. That's what our product is, and that's what we are doing for both LTE and 5G. And that allows you to kind of deploy these gateway nodes wherever they are, wherever you have fiber available or where you have cable available, and then you deploy mesh nodes where you don't have it available, similar to what we do it at home. So that's kind of a little bit background on what we do and what overall, I can give you a perspective of why we are doing 5G standalone end-to-end architecture. So here's kind of a brief block diagram of our 5G standalone architecture. So this is the testbed that we have created is an end-to-end testbed. It is ORAN. It is 7.2 split of ORAN, so the eSIPRI interface between the radio unit and the G node B. And it is using the Magma core with usual functions that are available in Magma core. along with its orchestrator. So here is kind of like a quick snapshot of some of the pictures of our equipment that is there in our lab. It's the speed test describing what we are able to achieve. We have been able to test the system with multiple UEs, like Samsung, S21, OnePlus, Pixel 6, some of the routers that are available from various vendors that support 5G SA, and we're doing all of this in both N78 and 48 spectrum. So both for CBRS as well as licensed spectrum. And so that's kind of like a brief overview of our activity. We've been grateful for the support that we have received from the Magma community, and especially with Kader and Parthipan, Suresh, and Yogesh and all of their team members. And we're looking forward to doing more. We provide a lot of feedback online, offline, so that we as a community can make a lot of improvement and take this thing forward. And some of it is actually already part of 1.8 release, which will be much better and much more stable on 5G SA. From a learnings perspective, we did like bringing up any generation system, whether we 2G, 3G, 4G, 5G. There are lots of OEM specific implementation and optional field that we have to track down so that the UEs are actually sending a PDU session request and not just waiting either for an anchor or have a different state machine flow under that. So adapting the core network solution to that. We kind of went through some of that in this exercise, and I'm pretty happy with where we are right now in the short amount of time what we have been able to achieve. So thank you, Suresh, Parthipan, for the opportunity for me to talk about this, and I'm happy to take some more questions here.
Thanks a lot, Hardik. So the excitement part is here. We have added one more GNB to test with Magma 5G core, and what is the more really glad news is all the test is done with the commercial UEs with like Samsung S21 and the OnePlus One and stuff. So it is really ready for Magma is really ready for a commercial deployment. That's to be really an exciting thing for all the people who are in the community now. So we should take it forward. And Wavelabs is committed to add a few more GNBs into the testing, interoperability testing with Magma. And we are on it, and it's in pipeline, and we could be glad to share it in the coming up meetings as well. Yeah, thanks to Hardik. Over to you, Suresh.
Yeah, in the interest of time here, let me check if there are any questions in the chat. There is one question that is already addressed. In case there are further questions, we can take up the questions through Slack channel. We are on the top of the hour. Thanks everyone for joining this session, particularly the co-host of this session, Hardik Jain. Thanks for your time today to bring your update into the meeting, and also your commitment to Magma community, Hardik. Thanks again to you, and also to entire Wavelabs team who have presented multiple features today as part of your update as well as through your demos. So that is end of update, and next session will likely to be in the second week of August. So there will be a upfront announcement. As usual, Kendall will provide update and then give heads up about the upcoming session. So with that, Parthipan, Yogesh, and Hardik Jain, can we go ahead and close the session?
Yeah.
Thank you.
Thank you. Thank you, Suresh. Thanks all. Looking forward to meet you all again then the next month meeting.
Thank you.
Thanks, everyone. Have a good day ahead.
Thank you all.